Happy Pi Day from GameSalad. I thought it would be a good day to show a fun way of calculating pi using the GameSalad engine. Pi is the ratio of the circumference of a circle to its diameter. The first three digits of pi are 3.14, so you can see why Pi Day is March 14th is Pi Day, or 0314. It was created in 1998 by Larry Shaw as a way to promote mathematics understanding. In 2009, the US House of Representatives recognized Pi Day officially, and in 2019, UNESCO made March 14th the International Day of Mathematics. Now we're going to use what's called a Monte Carlo method of calculating pi. Monte Carlo is famous for its casinos, and casino games are about random chance. So a Monte Carlo method uses random chance to perform calculations. Now let's look at calculating pi as a ratio of two different areas. The area of a circle is pi times r squared, or the radius squared. The area of a square is one side squared. Or in the case of a square that contains a circle, is the one side is 2r. And so you could say that the area of the square is 2 times r squared, or breaking it down, 4 times r squared. And so from that, you can say that the ratio of this area of a circle to the area of a square is the same as the ratio of the formulas. And if we divide out the r squared, you get the ratio of a circle to the square's area as pi over 4. And if we rearrange that a little, you get 4 times the area of a circle over the area of the square being pi. Now, how does that help us? Well, we can think of the areas as probability spots. So the circle area versus the square area could be, say, the probability of a randomly placed point being inside the circle versus being inside the total square. Or another way of looking at it is taking 4 times the number of random points that hit inside a circle versus the total number of random points is equal to pi. All right, let's build the Monte Carlo pi calculator in GameSalad. First, we'll need an actor that has a circle on it, which I've got a dartboard image I found online that's public domain. I've trimmed it so that it's exactly the size of the circle with just the square around it, which will help us with our calculations. I'm going to drag the actor or the image over to the Actors tab, which creates a dartboard actor. We'll make the actor a width of 768 pixels by 768 pixels high, which is the height of our scene in the default GameSalad scene. We'll also make the actor have a circular collision shape so that we can use that as a way to test the area inside and outside of the circle. Let's add our dartboard onto our scene, and let's align it. There we go. So the next thing we'll want to do, actually let's do 784 by 784, or 384, which aligns it almost exactly. And next, we'll want to be able to display our calculated value of pi. What we'll need is 2 values to track the number of darts that have been hit. So let's create an integer attribute for darts hit, which is the number of darts that hit the circle or our dartboard, and then another integer for the total number of darts thrown. So darts thrown. That would represent the total number of darts inside the area of the square. The darts hit would be the total number of darts inside the area of the circle. Now, if you remember, our calculation for for pi is 4 times the area of the circle divided by the area of the square. So let's do a display text, and we'll display an expression for game darts thrown divided by game darts hit times 4. We'll also want the text to be something a little more visible, so I'm going to make it yellow. And I'm going to make it left aligned so it doesn't move too much, and then I'm going to place it at 768 pixels to the right of the image, or actually to the right of the left side of the image, so right over here. The other thing I just thought of doing is let's round the number to an accuracy of 6 digits so that we don't have large number of decimal places showing, and we'll put the expression inside the round 2 function. So what this will do is we'll take the darts thrown divided by the darts hit, multiply that by 4, and round it to 6 decimal places. We'll update that, and then when we hit preview, we'll see not a number showing. Why is that? Because right now we're dividing by 0, and so that's not actually a number. or at least in the computer it's not. So the next thing we want to do is actually have some darts. So let's create an actor. We'll call it dart, and we'll make it 2 pixels high by 2 pixels wide, just so that you can see it, because a 1 pixel dot is very hard to see on the screen. And then we will set G green to 0 to make it magenta, so it's easily visible on our screen. So, all right, we've got a dartboard, we've got darts. Let's throw the darts. We'll have the dartboard actually handle the logic for throwing the darts by using what's called a timer rule. So what we want to do is every 0.001 seconds, just to make it very fast, we're going to want to spawn a dart actor. And we're going to want to spawn it in a random location, hence the Monte Carlo randomness, inside this square. 0, 0, when you're talking about relative to actor, is the center of the actor. So because the actor is 768 pixels wide, we know that we will want a value of plus or minus 384 pixels. So let's make a function where we randomly place the actor between negative 384 pixels and 384 pixels on the x-axis, and random value of negative 384 pixels and 384 pixels on the y-axis. All right. So this will now, every 0.001 seconds, spawn a dart actor in a random location in the square. Let's see what happens. Not a number. What's going on? Let's see here. Every spawn a dart actor. Oh, so if you see the preview, it is actually spawning dart actors, but there's no update to the count of darts, so it's showing not a number still. Next, let's have a dart actually track the values. Every time a dart spawns, we want it to change the attribute for the game darts thrown to game darts thrown plus 1. We also want to increment the dart hits, but only if you're in the circle. So what we can do is overlaps or collides with actor of type dartboard. And remember, we changed the dartboard to a circular collision shape, which means it only counts as colliding if it's within the circle contained inside the actor. So next, what we're going to do is change attributes and change the game dart hits to a expression for game dart hits plus 1. And we update. So now, when we preview, we'll see that we'll have a number that's a ratio between the dart hits versus the dart thrown divided times 4. Now, it's not quite right, it seems, because we should never get a value over 4. So let's go back and see what we did wrong. I have changing dart hits to dart hits plus 1. I have changing dart throws to dart thrown plus 1 when it overlaps or collides with the dartboard. And in the dartboard, I am displaying a value of game darts thrown over darts hit. That's a problem. How many of you saw that when I was typing? Let's change this instead to darts. Oops, I did it again. Let's change it from darts thrown to darts hit divided by the number of darts thrown. And then when we update and we preview, we'll see a number less than 4, and it's 3.6. And the idea is that over time, as more and more darts fill the screen, we'll get closer and closer to 3.14, our value of pi. The reason is, as we discussed before, the ratio of the area of the circle versus the area of the square times 4 results in pi. And so when you throw a dart, you have a chance of being in the circle versus the square. And by dividing the number of darts in the circle versus the total number of darts, that is equivalent of showing the ratio between the areas. And so over time, this number should slowly converge on 3.14, and you'll get a way of calculating pi that's very visual and kind of helps you see ways you can use the relationships of numbers and their physical space that they represent to calculate numbers like pi. We'll let this run for a bit, and we'll probably fast forward this as the video runs so that it'll go faster, but eventually this should hit 3.14, and that's kind of the target we're going for, since this method tends to get about 2 decimal places right. All right, as you can see, we've gotten to a stable around 3.14, and in theory, over time, we should be able to get even closer if we leave this long enough, closer to 3.141, then 1.415, 1.4159, and so forth. Hopefully you can see that's how a way you can use a game engine's programming system to help you visualize how the relationships between numbers can show interesting numbers like pi.